Convex lens A of focal length 20 cm and a concave lens B of focal length 5 cm are kept along the same axis with a distance d between them. If a parallel beam of light falling on A leaves B as a parallel beam, then distance d in centimeter will be A 15, B 50, C 30 and D 25. We are given a convex lens and concave lens. One is of focal length 20 cm and concave lens is of focal length 5 cm. While tracing the beam, we have a parallel beam falling on A and a parallel beam leaving B. We are also given there is distance d between them, which is what we have to find. We know convex lens is a converging lens, so the light beam gets converged, but before it converges and reaches its focus, it encounters the concave lens. And when it reaches concave lens, we know concave lens is a diverging mirror lens. But that is in case of a parallel beam. If a parallel beam falls on a concave lens, it will diverge and go in different directions. But here we have a converging beam, but in the question it is given that the beam then travels after B as a parallel beam. There is only one case for which a concave lens lets out a parallel beam. It is when the beam comes from the focus or appears to come from the focus. So when we trace the converging beam from the convex lens, it would go to the focus of the concave lens. And we know that the beam coming from convex lens converges to its focus. So we can understand that both A and B have the same focus. Since focus is the same, we have FA equal to FB plus the distance between them D. So we get D is equal to FA minus FB. FA here is 20 minus 5, which is equal to 15 centimeter, which is our option A.